curve. Input drive versus output. You want to run that amplifier in the most linear portion of the curve, not up here. Because you start getting into flat topping and splatter and all that kind of stuff. Now, what determines input power for an amplifier? Well, right about in here someplace. It depends on what tube you use or what's in the amplifier. The tube sensitivity to drive, the plate voltage, and the gain of the tube determines where you're going to operate here. In a 3500Z or an AL80P linear amplifier, maximum drive is usually about 100 watts based on a 3000 volts on the plate. That's how they determine that. If it was a 1500 watt amplifier using a big ceramic 8877, you can probably drive 1500 watts with no more than 40 watts of drive. That tells you that the tube is very sensitive to drive levels and doesn't need much drive to get that much power. That tube is also very expensive. So I just wanted to begin with that.
Excuse me, Ken, that's not the tube that's in the AL80B, is it?
No.
Okay.
The 3-500 is in the AL80B.
Okay, good.
The AL1500 is the 8877. Now that tube is about that big around and it's air cooled, forced air cooled. And it's also over $1,000 a tube.
Wow.
So you might be a little careful there. All right, here's.
Yeah.
All right, 3-500s and 3-400s.
All righty, I'm going to pass out a drawing of a linear amplifier without the power supply. Would you like to have it with this detail? It's probably all Greek to you.
$20.
Yeah,
A very bare bones schematic of a single tube AL80B with the 3500Z.
That's the 80B, right?
Yeah.
Down there, all right.
Okay. Remember a few meetings back we went through the operation of a tube.
Yeah.
Plate, grid, and this particular tube has a heater in it, no cathode.
Direct emission. Okay. Well, no power supplies, you know.
We supply 5 volts to that tube from the power supply. And these are RF chokes. The reason they're in there is because when you drive RF to that part, you want to keep it out of the power supply. You want to keep it all on this element here. That's the reason for the choke. The input is a parallel tuned circuit, usually. It's grounded. And usually the input, the coils are tuned instead of the capacitor. This is the input UHF connector. On the output, we supply voltage through another RF choke. And usually it's about 3 kV here. And of course, the other terminal is grounded. This is your reference here and your reference here. Now, how do we get RF power out of the tube? Well, we gotta have another coupling capacitor here to a tank circuit. Made a mistake here. Back up. Tuning capacitor inductor, another tuning capacitor to ground. This is called the pi network, after the Greek letter pi, because it just resembles it. And then we take RF out, and this is also the ground. Pretty much what I have on the paper.
Yep.
Okay. This tuned circuit makes it easy to drive the tube with low power. You could drive that tube without a tuned circuit, it would take a lot of power because the impedances aren't matched. So when this tuned circuit is resonant, the impedance goes down. And it's at that point there is where you're driving. It makes it easy to drive right in that area. In this case, it's 75, 80, 90 watts of power. We'll drive a 3500 to full output, about a kilowatt on peaks. You get out here on this pi network, you're going to have the same thing again. You're going to tune the plate and the load for what they call dipping the plate. You ever heard that term?
Oh, yeah, the 520 Ken went different places.
Yep, you get pretty good at it too.
All right, well, why does the plate current dip on resonance?
Because you matched it.
Well, the pi network is actually a parallel tune. And the impedance of the parallel tune circuit now goes up. So the plate current goes down, goes opposite direction. Make any sense?
Yeah.
That's why the plate current
Excuse me, we
dips.
had to not only dip the plate, we had also, some of the side dip the plate, you peak. So we had to dip the plate,
Right.
we also had to what?
Peak the grid, right?
Yeah, peak the grid, right?
Well, usually when you get a dip, the power is pretty much maximum.
Yeah.
Also, that is reflected back to the grid circuit. A lot of these amplifiers will have a grid current meter also, and you'll see the grid current goes down. Now, there's a lot more going on here than you might know. Since this tube is drawing current, it has a load resistance. And that load resistance, if you do Ohm's law, current and voltage, you come out with a resistance value. Well, let's say it's 1500 ohms. At, say, this point here. This pi network has to drop 1500 ohms to 50 ohms on the output. So right away, you got an impedance matching going on there. And you have the same thing to some degree on the input. The input impedance to that tube is around 100 ohms. And it's not static. It varies as your voice varies, because your current varies. This here will also vary. So you're going from 1500 ohms to 50 ohms through the pi network. And you resonate with the plate, and then the load is transferring from approximately center of that to the 50 ohm terminal.
Okay. What is the purpose of the coupling capacitor?
Block the DC.
Which one?
The one, right,
This one?
right, yeah, right there before.
All right, well, you got 3 kilovolts on that plate. You can't put 3 kilovolts out here.
It's DC, so you want to block the DC.
It's a blocking capacitor. And it's the same thing here. You have to isolate the input DC-wise from the AC.
He knows that, he's just asking.
No, I didn't.
Just testing.
No, yeah.
Now, I can bring something else that goes outside this HF amplifier. If you had a VHF or a UHF amplifier that was a tube type, you might use a series tuned tank circuit. If you use a series tuned tank circuit, when you tune that, plate current goes up, it goes the opposite direction. Because the impedance goes down, so the tube will draw more current. Also, when you adjust the load, there's something else going on. When you got an input signal coming into the tube, and it's 10 to 12 dB gain at this point, this tank circuit, we call it a tank circuit because now it has circulating currents back and forth. The voltages in this tank circuit can be up to 7 kilovolt, but it's RF. It's not this, it's in addition to this.
And it's okay to touch. RF's okay.
Yeah.
I'll watch you.
I stick your head in the microwave.
Nice burn.
Let's see, what did I say here?
Okay. So we part of it, and I'll give it to my okay.
Question. Ken?
Okay, question.
This circuit is basically designed for single sideband? Or
Well,
AM?
you can operate it FM, CW, single sideband.
It's
and
not as
AM.
much the signal type as you're in the linear mode.
Okay.
Other amplifiers don't operate specifically in the linear mode. They're a little more complex to design.
Right.
And you may get a lot more out of them, but they're not nice and simple and easy like this. It's real easy just to keep it in that linear region. So it could be AM, FM, doesn't really matter what the modulation is, as long as when it does its excursions, it stays in that linear region.
So the only exception to that would be FM.
Right.
FM doesn't depend on being so linear,
Yeah.
because it's just a frequency shift, not an amplitude shift.
Right.
That's the difference. But you don't want to run an amplifier over the knee at the top anyway. You really don't want to do that. You're not gaining anything. The power doesn't go up any further, and you're just dissipating a lot more heat and being harder on the tube. So you don't want to do that.
And harder to understand.
Yeah.
Saturation.
Okay, the value of this coupling capacitor here has to have a voltage rating of 7 to 10,000 volts. Because you already got 3 kV on there and whatever you develop in the tank circuit on top of that, so it has to stand the potential difference between the plates. That doesn't occur back here, where the voltage handling ability can be much, much lower, maybe 1,000 volts or less. Okay, you might want to turn the paper over. Let's see.
Blank.
Oh,
I have one of those.
Mine's
No,
not.
I have some of mine.
Mine's not, yeah.
They're backside of that,
Let's
this
see if I
side.
can do this.
Mine's
guy.
not.
Well, the backside is this side.
Oh, yeah, mine's got an amp on it.
Yeah.
If you take this output,
What the heck? No, right here.
connect it to an
See?
antenna,
Mine has some.
Yeah, because you got 2 papers.
you take the output and connect it to an antenna, and the impedance at the feed line is not 50 ohms. What we usually do is add a tuner in line.
Okay.
The basic tuner is very familiar. I'll draw it down here. Looks like a pi network, just like that. Now, the difference is the input will be 50 ohms. The output can be anything that these
Can handle.
L to C ratios will permit. From, say, 15 ohms to maybe 1,500, 2,000 ohms, depending on what antenna you're going to use. You got to check the tuner manufacturer's specifications as to what the impedance match range is. If you pick one that's not wide enough, it won't work.
Not only that, but if you have to tune that much, well, your signal's inside the tuner.
Oh, yeah.
So, you don't want to. So you want your antenna to be as close as possible from the get-go.
Now, there are other configurations for tuners. You have them for open wire line, ladder line. You have them with a bound built in, a one-to-one bound. End-fed antennas, stuff like that. So you have to choose your tuners to match what kind of antenna you're gonna use.
I know like the Heathkit tuner takes bound, unbound, single wire, it doesn't matter.
So, let's go back to the tube again. The plate offers an electrostatic lines of force that reaches right through the grid, trying to pull electrons from the cloud through that grid to the plate. Now, this all happens in a vacuum. This is about one of the few times where electrons actually flow. Once it gets out of the plate, there's another conversion that takes place, but we won't go into that.
Next week.
Ken, the 3500Z2, that's in the 80B?
Yep.
What temperature does that attain that to?
376.2 Kelvin.
What?
Sorry.
No, what temperature does that?
It
You
gets
talking
hot.
about the heater?
It gets hot.
No, how hot does that actually get?
Well, you have to stay below the point where the anode would melt,
Right.
and that's way above where you'd ever want to go.
That's
But
why
that's cool, right? That group is cool.
you have a fan blowing
The
over. That's
500
why.
designation means 500 watt dissipation on the plate, that's the limit.
That's right.
And then you can't do that forever,
Right.
Right.
because you break the glass.
But what would you say the temperature that tube actually gets at
300-400 degrees,
Is that,
maybe more.
I've never actually measured it, but I would say probably maybe 300 degrees F.
really? That's
Somewhere
hot.
in that area.
That's what I'm
Now, when you turn on the linear amplifier, the first thing you see light up is the heater.
Right. Right.
Well, now you can get some feel for what we call color temperature. You'll see that will be somewhere in the bright orange spectrum. That's somewhere between 900 and 1100 degrees Fahrenheit. And it's made out of a tungsten alloy, which boils off electrons when it gets that hot. That's how you get the electron cloud to pull, the plate pulls from. And the drive, along with the tuned circuit, is operating between,
48 tungsten.
is oscillating back and forth in this part. And the plate current that is drawn by the electrons, you're actually modulating that electron flow or reproducing the signal.
And amplified.
So the signal, your drive signal does pass through, but it's only causing a reproduction of itself through the power supply. The power supply couples energy through this coupling caps to this tuned circuit, and it keeps banging it every cycle. And you gotta take power out to the antenna where you can't put anything in.
I have a question for you. Let's go into amplifiers, let's go into audio at the same time. When you're using audio and you go into a downward expander and you bring that audio up where the output of that tube does not change, you're keeping it at maybe 900 watts. In other words, your output on your meter is not dropping because you got the downward expander energized and it's keeping that tube putting out 900 watts. So you're actually shortening the life of the tube, am I correct?
Well, you would if you went too long. Since you're talking, your average voice audio is low.
Right.
Average is low.
Right.
But what you're talking about is compression,
Right.
audio compression. The downward expander is something different.
Okay, audio
Shut the
compression.
mic off until you talk, and then the downward expander comes, opens the audio circuit to the drive.
Okay,
So you're talking about compression.
right.
Yeah, you're trying to raise low signals and
Yeah.
lower high signals.
Yeah. So what happens with the linear, when you do use a lot of compression, you're raising the average plate current very high. And that makes the tube work pretty hard.
Okay,
So if you were to use it on AM, where you have a constant carrier, plus the peaks, you gotta watch the tube, because if you're driving too hard, the plate gets redder and redder and redder and redder, and you don't want to go too far too often. Because that pulls a lot of the emission out of the heater. So usually on AM, you might not want to drive the tube any more than a carrier of about 100 watts.
Joe, all right.
If you have 100% modulation, your peaks will be 400 watts.
that's what I do, I drive 100.
That'll be 100 watts below the rating of the tube.
Right,
But you don't want to hold the key down too long, talk too long, more than maybe 2 minutes or so. Because it's pretty hard on the amplifier. It wasn't made to do that. But you can if you lower the operating level.
okay.
Ken, what made them change from 3 tubes to the one, like the 3500Z? Why did they go from 3 to 1 tube? Wasn't there originally 3 tubes in the linear amp?
So, well, some of their designs,
Only problem is
like the 572 and 811s had 4 tubes in it.
So why would they try to compress them into 1 tube to do all the work, right?
Trying
Well,
to make the amplifier
to
cheaper.
lower the price.
Money.
Oh, really?
Lower the price.
Cheaper.
You can buy a 2-tube AL 85.
Yeah.
Has 2 3500s in
Right.
it. And you can run 1500 watts with that unit.
And then low.
Or Drake L4B,
Really?
that has 3-400Zs in it.
Gives you
So how
more
many, you have 2 300?
2.
2, okay.
Gives you more overhead.
Right.
Really?
Well, you're probably running in like an AB or something.
Yeah.
Yeah, but aren't you putting
Each
more
cycle-
stress on 1 tube than 1 tube?
Well, you're spreading, what happens in a situation like that is you have a sine wave doing that, while the top part is 1 tube.
Right.
The bottom part is the other, the top part is matching that crossover.
That's right.
That phase has to be matched very carefully to get distortion. Because if the output doesn't look exactly like the input, it's distorted, period, no matter what whether it's audio, RF, doesn't matter.
Right.
You can make it bigger, but it has to keep the same shape. If
Right.
it doesn't, you've distorted it.
Yeah.
So all they do is take that linear region of the tube, and instead of having the whole signal on it, only half of it is, so that can be, more or less twice as much.
Right.
It's not actually twice, but, it's a lot more. And then you do it with the bottom cycle, and the idea is if you match them very carefully, you now have an AB amplifier. And it will now give you more, each tube is being better utilized, put it that way.
Well, to just drive a little bit further on that, on VHF amplifiers, if you use 2 tubes and configure them in a different configuration electrically, push-pull, only 1 tube is working at a time, alternate back and forth. In HF, they'll take the tubes in parallel in order to double the power. That's the difference.
That's a neat way, yeah.
Now, how would you tune up one of these for AM use?
Carefully.
Low power.
Well,
Carefully.
you decide what you're going to do for drive. Most radios will have 25 watt AM carrier. And 100% modulation would be 100 watts. Well, the factory sees fit to not allow you to go 100%.
Right.
Throttle it back to maybe 90% to keep the radio clean. Because they don't want a reputation for putting out a dirty radio.
Right.
So, when you drive an amplifier like this with 10 or 12 dB gain, you're only going to drive in here 5 to 8 watts in order to get a 100 watt carrier out.
Wow.
Okay?
But then you're gonna modulate it up to 400.
Well, that's yet to come. When you tune up, you're going to raise your power to get the amplifier to put out about 400 watts CW. Because now when you drop back to your AM drive level, your voice peaks don't go over 400 watts. It stays within the linear tuned area that you, not 800, 900, or 1,000 watts, only 400 watts, because you're not driving beyond that. If you do that with a 400 watt tune, you're gonna flat top.
On the RFC amplifier, I thought about an FM, because I have, it's 30 watts, it's 165, whatever it is, out. You always told me, don't drive it at the full 30, drive it lower than that. I think I drive at 20 or 25 at max.
Yeah,
So
that was-
we don't go to max on that.
That was for single sideband use.
Right.
The power ratings for the brick amplifiers are for FM. It's up to you to understand that you can't drive them like that on sideband or AM. You just can't do it.
So it says 30 in and out, don't drive it the whole 30.
No.
So you
You
should
wanna-
have ruled it about 80%.
Here's another example, like you just brought up. It mirrors this. If the brick amplifier will take 30 watts of drive on FM, all you want to do is set up your AM drive to reach 30 watts peak. And then you even want to draw that back to about 5 watts in order to be sure that you're not going over the top.
Which means your average is probably pretty low.
Yeah.
Yeah, you told me that, you always mentioned it to me that.
And then your output will probably only be 110 watts or so in order to just stay clean.
Yeah. So if you're driving at the full, then you're just storing the signal on it, right?
Oh, yeah.
Oh, yeah, big time.
Yeah, big time, yeah.
Not only that, your bladder is
Really
All
okay.
over the place.
I had everything separated and in my book.
Now, let me,
I was like, uh-oh.
Let me enter one other thing here. How far can you move in frequency on one tune-up? If you tune up at one frequency, like say 40 meters, 7,200, how far up or down can you go before you have to retune?
Depends on your antenna too.
Oh, yeah.
Yeah.
Well, let's stay with just the amplifier for now.
Perfect at that.
That, how far you can move depends on the input circuit Q and the output circuit Q. Most of the time you can move about 50 kilohertz
Right.
That much?
Deeper than
before you have to retune it. As soon as you move off there, your power starts to drop. Now, what constitutes Q? Well, Q, if you look at a tuned circuit this way, Q is the width of the tune at some point down the slope.